Hi everyone and welcome back. In this class we are introducing lists in Prolog. It's a fundamental concept and a very useful and powerful way of programming applications in Prolog is by the use of lists. A list is a simple data structure and is basically a sequence of elements. Here we have an example of a list of 4 elements. Alright, we have Anne, tennis, Tom, and skiing. Each of them is an element that belong to the list. Now, any given list is represented by the first item of the list, and this is called the head of the list. So in every list, every non-empty list, the first element of the list is called the head of the list. And then we have the remaining part of the list, and that is the remaining list, and we call this list the tail of the list. In this example list we are dealing, we have that N is the head of the list, and then the remaining list is the elements, and the list with elements tennis, Tom, and skiing. Then we conclude that this list, tennis, Tom, skiing, is the tail of the initial list. We can view lists and represent them with trees. Every tree has a root node in this case, and in the case of the data structure of lists, the root node of the tree is a point. And what's very important is that the left child of the list is the head of the list, and the right child is the tail of the list. So in the first case, the head of the lists, the original list, this one with the 4 elements, N, tennis, Tom, and skiing, then the head is N, so the left child is N, and then the right child is another list. So all this is the tail of the original list. And if we break down the tail of the original list, we see that it is another list, which the head of this tail is tennis, right? Now we're analyzing only the list tennis, Tom, skiing. Well, the head, the first element of this list is tennis, and the right child is the tail of this tail, and this is another list, which elements is Tom and skiing, and so on. We keep on doing this when here the first element is Tom, and finally the last tail, we see that the first element is skiing. And what happens when the remaining list is empty? Well, when the remaining list is empty, this is when the list has only one element, that is this case, the first element and is skiing, and it's only the only element of the list. The right side is the remaining list, and this empty we just represent like so. This is the empty list. So this is the tree representation of lists in Prolog. So this concept here of the notation of the first item being the head, the first element being the head, and then the tail being the remaining list is a very important concept in Prolog. We will be working with many problems when we have to know this representation. Right, so now we will learn a very important notation in Prolog of lists. Suppose we have the following lists with 3 elements, the elements A, B, and C, and basically here we can easily come to the conclusion that A is the first element of the list, that is, A is the head of the list, and then BC is the tail of the list, right? The remaining list if we remove the first element. So Prolog provides us another very powerful notation to separate the head of the list from the tail of the list, and this is with the operator and of the vertical bar. So this vertical bar symbol separates the head of the list, that is A, from the tail of the list. And this is another way to represent this list ABC, saying that A is the head of the list and tail is the remaining list. And of course we have that the tail, this is the remaining list, is BC, right? So there are many ways we can represent lists. Okay, this is the usual way, and we have only this way in normal humankind, right? However, Prolog provides us with another incredible notation that is with this vertical bar. Okay, for recursive problems, we'll see, and advanced problems, this notation is extremely powerful. Okay, so this is very important to keep in mind. Let's see more examples from these lists using this notation. And in fact, this vertical bar is a very general notation, and this allows us that we can use it to separate the list as we want. Suppose this case, like just consider we have the original list, that is the list ABC. So we can in fact use it for separating the head and the tail. As you see, A is the head and the tail is the remaining list BC. But we can also say that, well, the first element is AB and the remaining elements is C. Okay, this is also a possible way to represent this list L. Okay, another one is that, okay, so I have the list L with the elements A, B, C. So this is equivalent to say that the first element is the elements A, B, C, and the remaining list is the empty list. Okay, that is, we have no more elements. When the remaining list is the empty list, this is the same as saying the tail of this list is an empty list. So this means that we have no more elements. Okay, and these are other examples of seeing this vertical bar notation. So finally, summarize all the knowledge. A list is a basic data structure that is a sequence of elements. It is either empty or it consists of two parts: the head of the list, who is the first element of the list, and the tail is the remaining list. All right, so the tail itself has to be a list. Prolog provides us a special notation for lists with the vertical bar, so we can use this vertical bar, or we just write the lists with the sequence of elements, or we can use the vertical bar to separate the head and the tail, or just to separate the items with the other items. Okay, what is important is that when we have to put anything after the vertical bar, this has to be a list. Okay, so tail has to be a list, and these others is a variable that also must be a list. Okay, so with this we finish the class of the introduction to lists in Prolog. See you in the next class.